Hi friends, in this video we are going to discuss about effect of harmonics on speed. You have to know first what are harmonics. Tell me, what is the definition of harmonics? Harmonics definition. What is the definition of harmonics? Harmonics nothing but the integer multiples of fundamental frequency. Integer multiples of fundamental frequency is called as harmonics. Integer multiples of fundamental frequency is called as harmonics. For example, if you take the fundamental frequency 50 Hz, its integer multiples. Integers nothing but 1, 2, 3 and so on. Integer multiples nothing but 50 Hz. Of course, this is fundamental. Into 2, 100 Hz. Into 3, 150 Hz. Into 4, 200 Hz. And these are generally called as harmonics. What are harmonics? The integer multiples of fundamental frequency is called as harmonics. For example, I am taking 1 is my fundamental. For this, what are harmonics? For fundamental, the harmonics are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and so on. These all are the integer multiples of 1. That's why these all are the harmonics. But generally for our sinusoidal analysis, the waveforms which are symmetrical to x-axis, the waveforms which are symmetrical to x-axis, are generally for sinusoidal analysis. Wherever you go for sinusoidal analysis, even harmonics are eliminated. Automatically, even harmonics are eliminated. Generally in Fourier analysis, in Fourier series, generally we can find out A0, A1, A3, B0, B1, B3, but there is no A2, A4. There is no B2, B4. Why, sir, there is no A2, A4, B2, B4? Because the even harmonics are automatically eliminated. Those values are 0. So we have only odd order harmonics 3, 5, 7 and 9 and 11 and 13 and 15 and 17 and 19 and so on. Now these are the remaining harmonics. Even harmonics eliminated, completely eliminated. In our electrical subject, we saw even harmonics only in one place, in magnetic inrush currents of transformer. At that place, the waveform is not symmetrical to x-axis. That's why in magnetic inrush currents, second harmonics are present. And mostly we didn't see anywhere about even harmonics, only in magnetic inrush currents. Right, of course, still then after we have only odd order harmonics. These odd order harmonics divided into 3 groups. One is triple N harmonics. Triple N harmonics nothing but 3 into 1, 3, 3 into 2, 6 already eliminated, 3 into 3, 9, 3 into 4, 12 already eliminated, 3 into 5, 15 and so on. 3, 9, 15 and so on. These are triple N harmonics, or is also called as third group harmonics. Triple N harmonics are third group harmonics. Another one, 6n minus 1 harmonics. 6n minus 1. 6n minus 1 nothing but 6 into 1. 6 minus 1, 5. 6 into 2. 6 into 2, 12. 12 minus 1, 11. 6 into 3. 6 into 3, 18. 18 minus 1, 17 and so on. These are 6n minus 1 harmonics are fifth group harmonics, which are this one, 5th and 11th and 17th. These are the 6n minus 1 group harmonics. And next one, 6n plus 1 harmonics. 6n plus 1 nothing but 6 into 1 6, 6 plus 1 7, 6 into 2 12, 12 plus 1 13, 6 into 3 18, 18 plus 1 19, and so on. These are the 6n plus 1 harmonics or 7th group harmonics. 7th group harmonics, which are, these are 7, 13, 19, and so on. These are the triplet harmonics, 6n minus 1 harmonics, 6n plus 1 harmonics, 3rd group, 5th group, 7th group. Generally, we have a fundamental frequency parameters like this. These are the fundamentals. For example, this is R1 and this is Y1 and this is B1. Each are displaced by 120 degrees. Each are displaced by 120 degrees. Right? Now I want 3rd group harmonics. 3rd group. How they are 3rd group and how they are 5th group and how they are 7th group. We have to calculate. First of all, R1 at 0 degrees, Y1 at 120 degrees because 0 plus 120, and B1 at 240 degrees. B1 at 240 degrees. This is at 0 degrees, this is at 120 degrees, and this is at 240 degrees. 0 plus 120, 120 plus 120. And 240 plus 120 is 360, nothing but 0. 0, 120, 240. Right. Now, just see first of all, 5th group harmonics. How we can get 5th group? The R5 should be at 0 into 5 is 0. R okay. What about Y? Y5 nothing but Y5. Y actually at 120, but 5th group, that's why 120 into 5, 120 into 5, 600, 600 nothing but 240. 600 minus 360. 600 minus 360 is the 240. So Y5 at 240 degrees, R5 at 0 degrees, and B5 nothing but 240 into 5. Actually B1 at 240, B5 that's why 240 into 5, nothing but 1200 degrees. 1200 degrees is also equals to 120 degrees. If we started here, 360, 0, 360, 0, 360, 0, 360 nothing but 900 plus 180, 900 plus 180, 1080, 1080 nothing but 0, 1080 nothing but 0, but 1200 nothing but 120 degrees. 1200 nothing but 120 degrees. What about this 5? R is at 0 degrees, Y is at 240 degrees, and B is at 120 degrees. B is at 120 degrees. Nothing but how they are. This is my R5, and this is my B5, and this is my Y5. Now the flow is like this. Actually see here. Here RYB in clockwise direction. RYB. But see here RYB in counterclockwise direction. This is clockwise direction, but here counterclockwise direction, but each are displaced by 120 degrees only. But rotates in reverse direction. That's why the 6n minus 1 group harmonics is also called as negative sequence harmonics. 6n minus 1 group harmonics is also called as negative sequence harmonics, or 5th group harmonics is also called as negative sequence harmonics. Okay, 5th group harmonics are called as negative sequence harmonics. What about 6n plus 1 harmonics? Or what about 7th group harmonics? Yeah, opposite. If this is negative sequence, this should be positive sequence. Let's check it. Is it is positive sequence or negative sequence? We have to check it. First, see this is carefully. Okay, I'm going to rough this. Okay, are you okay? Clear up to now? Now I'm going to give you clarity about seventh group. Right, now I want to find out seventh group. R7 and Y7 and B7. R7 nothing but 0 into 7, 0. Y7 nothing but 120 into 7, 120 into 7, 700 plus 140. 700 plus 140, 840, 840, 840 minus 720. If we started here, one is the 360 and another 360. Nothing but 720 completed. Minus 720, nothing but 120 degrees. Nothing but Y7 at 120 degrees. And next one, B7 nothing but 240 into 7. If we calculated this one, 240 into 7. If we calculated this one, 1680 nothing but 240 degrees. 1680 nothing but 240 degrees we can get. Right, now R7 is here, and Y7 is here, and B7 is here, nothing but this is flows in clockwise direction only. This will flows in clockwise direction only. But each are displaced by 120 degrees exactly. Each are, see here, this is also clockwise direction and this is also clockwise direction. That's why the 6n plus 1 harmonics are called as positive sequence harmonics. And these are called as negative sequence harmonics. Getting or not? Yes? The fifth group are 6n minus 1 are called as negative sequence harmonics. Seventh group or 6n plus 1 is called as positive sequence harmonics. Negative sequence harmonics. Can you guess what are these are called as? Third group are triple N harmonics are called as. Tell me. Yes, do here. Again do here. Now I want R3. I want Y3. I want B3. I want I3. R3, Y3, B3, nothing but 0 into 3 is 0. Nothing but my R phase at 0 degrees. Next one, 120 into 3, nothing but 360, nothing but 0 degrees. Yes or no? 360, nothing but 0 degrees, nothing but Y3 also here only. Y3 also at 0 degrees. Next one, 240 into 3, nothing but 720 degrees. 720 nothing but 360 and 360. Once a 360, once a 360. Again 0 degrees. Nothing but again B3 also at 0 degrees. There is no any rotation. There is no positive rotation. There is no negative rotation. It is not a positive sequence. It is not a negative sequence. What is the sequence? There is no rotation, 0 rotation, or all are at 0 degrees. That's why the third group harmonics is also called as 0 sequence harmonics. These are also called as 0 sequence harmonics. And these are called as fifth group are negative sequence harmonics, and these are called as positive sequence harmonics. Right? So finally, what is the conclusion is that third group harmonics are triple N harmonics are 0 sequence harmonics. 6n minus 1 harmonics are fifth group harmonics are negative sequence harmonics. 6n plus 1 harmonics are seventh group harmonics are positive sequence harmonics. These harmonics are more effective in transformer. The transformer EMF equation decided by this third harmonics. But these fifth and seventh harmonics are more effective in induction machine. These fifth and seventh harmonics are more effective in induction machine. Fifth and seventh harmonics are more effective in induction machine. But these all the harmonics are more effective in synchronous machine. EMF is there in synchronous machine and rotation is there in synchronous machine. But there is no rotation in transformer. And generally the EMF of the induction machine is not generally required. So in transformer, triple N harmonics are most effective harmonics. In induction machine, fifth and seventh harmonics are most effective. In synchronous machine, all the harmonics are most effective. All the harmonics are most effective. Now, in induction machine, we have to concentrate on fifth and seventh harmonics. We have to concentrate on fifth and seventh harmonics, right? This is simply about the harmonics. Fifth group, seventh group, third group. Zero sequence, negative sequence, positive sequence. This is very important, sir, about harmonics. Very important. What is definition of harmonics? Tell me definition. Integer multiples of fundamental frequency. What is integer? 1, 2, 3, 4, 5, 6, 7, and so on. What are harmonics? These are positive sequence harmonics are eliminated. Negative sequence harmonics divided into three groups. Triple N, 6n minus 1, 6n plus 1. This is simply about harmonics. Now we have to go for effect of harmonics on slip speed characteristics, or simply the effect of harmonics on speed. Okay, so now in induction machine, 6n minus 1 and 6n plus 1, fifth group and seventh group, negative sequence harmonics, positive sequence harmonics are most effective. Due to these harmonics, the rotor speed is equals to ns by fifth constantly. Due to this harmonics, the rotor constantly rotates at ns by fifth. Due to this harmonics, the rotor constantly rotates at ns by seventh speed. Ns by fifth nothing but ns by 6n minus 1. This is nothing but ns by 6n plus 1. The rotor constantly rotates at this speed. The rotor constantly rotates at this speed. Generally, if we draw the speed torque characteristics, the characteristics of induction motor and the characteristics of induction braking. Here NR is equals to 0. This is motor. This is braking. Motor nothing but this is NR is equals to NS, nothing but positive sequence. This is NR is equals to minus NS. NR is equal to minus NS, nothing but negative sequence. Positive sequence, negative sequence. Positive sequence, negative sequence. NR is equal to NS by 5. NS by 5 nothing but minus NS by 5 nothing but the speed is here. Generally the speed is like this. When NR is equals to, for this, NR is equal to NS by 7 nothing but the speed is like this. So nothing but negative sequence nothing but in braking mode, positive sequence nothing but in motoring mode. Finally, the curve is like this. Nothing but, generally see here the motor constantly rotates at this point. The motor constantly rotates at this point only. Okay? So, here the motor constantly rotates at this point. This phenomenon is called as This phenomenon is called as very important one. This phenomenon is called as crawling. This phenomenon is called as crawling. This phenomenon is called as crawling. Tell me, what is crawling? What is crawling? What is crawling? Generally, this is my induction machine. If three-phase AC supply given to my motor, three-phase AC supply, rated three-phase AC supply given to my motor, even though the rotor constantly rotates at ns by fifth or ns by seventh speed constantly. Even though rated three-phase AC supply given to the stator, the rotor constantly rotates at ns by fifth or ns by seventh speed. This phenomenon is called as crawling. What is definition for crawling? Even though rated three-phase AC supply, rated three-phase AC supply, even though rated three-phase AC supply given to three-phase induction motor, even though rated three-phase AC supply given to three-phase induction motor, the rotor constantly rotates at ns by fifth or ns by seventh speed without acceleration. Even though rated three-phase AC supply given to the three-phase induction motor, the rotor constantly rotates at ns by fifth or ns by seventh without acceleration because of fifth and seventh group harmonics. Because of fifth and seventh group harmonics. This phenomenon is called as crawling. Right? What is crawling? We got it. Crawling. Even though rated three-phase AC supply given to the three-phase induction motor, the rotor constantly rotates at ns by fifth or ns by seventh speed without acceleration because of fifth and seventh harmonics. Fifth and seventh group harmonics. This is called as crawling. Now they are asking questions. Crawling in induction motor due to crawling in induction braking due to crawling in induction generator due to. Tell me. Crawling in induction motor due to positive sequence harmonics, nothing but seventh harmonics. Crawling in induction braking due to negative sequence harmonics, nothing but fifth group harmonics. Crawling in induction motor, seventh group. Crawling in induction braking, fifth group. Crawling in induction generator. Actually, crawling will occur in this place only because ns by seventh here, ns by fifth here. But in generator, the speed is greater than ns. In greater than ns, do you find any ns by seventh or ns by fifth? Sir, it is already ns crossed. There is no possibility of ns by fifth and ns by seventh. There is no possibilities of ns by fifth or ns by seventh. That's why in induction generator, no crawling. Actually, this is very silly question. How the crawling will be takes place in induction generator? Generally, it is generator. Generator nothing but the mechanical supply given by you itself. You are going to rotate the prime mover at what speed? As you are required. How it will rotate at ns by fifth or ns by 7? That is given by me, right? I am going to rotate at synchronous speed, right? Or greater than synchronous speed. How it will be at ns by fifth or ns by 7? It is very silly question. In generator, there is no crawling. Now, in induction machine crawling due to. In induction motor 7, induction braking 5th, induction generator no crawling. In induction machine crawling due to 5th and 7th harmonics. Because induction machine nothing but motor or braking, both. Induction machine works in how many modes? Braking mode, motoring mode, as well as generating mode. That's why 5th and 7th. Induction machine 5th and 7th. Induction motor 7th. Induction braking 5th. Induction generator no crawling. Induction generator no crawling. Okay, so this is about crawling. Okay, sir, I know crawling is there. I know crawling is there. How we can eliminate the crawling? Tell me. How we can eliminate the crawling? By using short pitch winding, we can eliminate the crawling. By using short pitch winding, we can eliminate the crawling. What is the short pitch angle? What is the short pitch angle? For short pitch winding, what is the short pitch angle? Let's see. What is the short pitch angle? Let's see. By using short pitch winding, we can eliminate crawling. By using short pitch winding, by using short pitch winding, we can eliminate crawling. We can eliminate crawling. We can eliminate crawling. We can eliminate crawling with short pitch angle. Short pitch angle. Alpha is equals to 180 by n. Short pitch angle alpha is equals to 180 by n, where n is the, what is n? Order of harmonics. Order of harmonics. Where n is the order of harmonics. Okay? N is the order of harmonics. Now the question they are asking. First question. How we can eliminate, or to eliminate crawling in induction motor. To eliminate crawling in induction motor, alpha is equals to, or to eliminate 7th order harmonics. 7th order harmonics, alpha is equals to eliminate crawling in induction motor, nothing but to eliminate 7th order harmonics, alpha is equals to 180 by n. Nothing but 180 by 7. 180 by 7, nothing but 25.5 degrees. If we are using 25.5 degrees of alpha, then we can eliminate crawling in induction motor. Nothing but we can eliminate 7th order harmonics. First question. Second question. To eliminate crawling in braking mode. To eliminate crawling in braking mode, alpha is equals to, or to eliminate 5th order harmonics. 5th order harmonics, alpha is equals to 5th order right, or braking mode, nothing but negative sequence, nothing but 5th order harmonics, nothing but 180 by 5, that is equals to 36 degrees. 36 degrees. These are very, very, very important questions. I will give you another very important than these two. Is it visible? Okay, visible. Right, see. To eliminate crawling in induction machine. To eliminate crawling in induction machine, alpha is equals to, or to eliminate 5th and 7th order harmonics. 5th and 7th order harmonics, alpha is equals to, can you tell me the answer? Very important, very tricky question. To eliminate crawling in induction machine, they won't ask you induction motor. If they ask you induction motor, 25.5. If they ask you induction braking mode, 36. But they asked induction machine. Machine nothing but motor, generator and braking. Motor, generator and braking. So tell me what is answer for this. To eliminate 7th order, 180 by 7. To eliminate 5th order, 180 by 5. But to eliminate both 5th and 7th order. What is answer? Sir, what is answer? The answer is 36 plus 25.5. 36 plus 25.5 by 2 is nearly 30 degrees. 36 plus 25.5 by 2, nearly 30 degrees. To eliminate crawling in induction motor, 180 by 7. Crawling in braking, 180 by 5. Crawling in generator, if you said crawling in generator, is it wrong answer? Because in generator, no crawling. Right, next, to eliminate crawling in induction machine, both 5th and 7th, that's why the average of these two, nearly 30 degrees. Actually, its value 30 point something. But in generally, we are taking 30 degrees. Is enough. We can eliminate crawling. So, what is crawling? Before that, what are harmonics? And what is the effect? That is crawling. And how we can eliminate crawling? By using the short pitch winding. By using the short pitch winding, we can eliminate the crawling. We can eliminate crawling. See once clearly. Okay, one is completed. Effect of harmonics. In that, one effect is crawling. And another effect is cogging. Another effect is cogging. So what is cogging? What is cogging first of all? What is cogging? Generally, in our machine, we have a stator and rotor. For example, my stator is like this. Actually, it should be like this. I am cutting it like this. I am taking here. I am taking here. I am cutting like this. I am taking here in separately. For example, like this. And again, these are my rotors. These are my rotor. This is my rotor, for example. For example, I am taking the stator slots and rotor slots. Stator slots and rotor slots. For example, this is stator. And next one, this is my rotor. This is my rotor. These are my stator slots and rotor slots. These are stator slots and rotor slots. Here we are using stator winding. Here we are using stator winding. And here we are using the rotor winding. When the stator is given by three-phase AC supply, then some flux will produces. Due to mutual induction, here also flux will develop. Then due to these two fluxes, some attractive force will develop here. Some attractive force will develop here. In between two teeths or in between two slots. In between two slots or in between two teeths, some attractive force will develop. That is nothing but magnetic locking. Will takes place in between these two. Nothing but the rotor slots magnetically locked with the stator slots. The rotor slots magnetically locked with the stator slots. Rotor slots magnetically locked with the stator slots. Generally, what is the speed of the stator slots? 0. That's why our rotor slots also at 0 speed. Actually, the speed of the stator slots is 0. That's why our rotor slots also at 0 degree, at 0 speed. This phenomenon is called as cogging due to magnetic locking. So what is definition for cogging? Cogging nothing but even though rated three-phase AC supply, given to three-phase induction motor, the rotor doesn't start rotation. The rotor does not starts rotation due to magnetic locking of rotor slots, due to magnetic locking of rotor slots with the stator slots. Magnetic locking of rotor slots with the stator slots. This phenomenon is called as cogging. This phenomenon is called as cogging. Even though rated three-phase AC supply given to the three-phase induction motor, the rotor does not start rotation due to magnetic locking of rotor slots with the stator slots. This phenomenon is called as cogging. Generally, cogging arises in low starting torque machines. Nothing but the cogging effect is more in more in squirrel cage induction motor. Cogging effect less in slip ring induction motor. If in slip ring induction motor cogging effect takes place, what we have to do? By adding the extra resistance, we can increase the starting torque. Then that starting torque disturbs this magnetic locking. That's why there is no possibility in slip ring induction machine, because the slip ring induction machine having the high starting torque by adding the extra resistance. Yes or no? By adding extra resistance, we can avoid this cogging. But in squirrel cage, there is no possibility to add extra resistance. That's why we have to do something. So whatever, in squirrel cage induction machine, cogging effect is more. In slip ring induction machine, cogging effect is less. And in generally, in induction generator, there is no cogging. In induction generator, there is no cogging. There is no cogging effect in induction generator. No cogging effect in induction generator. Right, sir, this is about cogging. Okay, cogging came. How we can avoid the cogging? To avoid the cogging, the number of slots we have to change. Up to now, actually, this is the slots. The number of slots are equal. Actually, the stator number of slots is equals to rotor number of slots. If rotor number of slots are changed, for example, I changed my rotor number of slots. For example, now there is no cogging effect actually. Just here some cogging effect. Next, there is no cogging effect. There is no here just cogging effect. And of course, just a small. For example, if we take like this up to here, there is no cogging effect in this place. Nothing but by changing. So to avoid cogging, first one, the rotor number of slots should not be equals to stator number of slots. And next one, the stator number of slots minus rotor number of slots. Stator number of slots minus rotor number of slots should not be equals to n into poles. N is the integer 1, 2, 3, 4, and into poles. N is the integer 1, 2, 3, and so on. So the first condition, the rotor number of slots should not be equals to stator number of slots. Second condition, the slots of the stator and rotor, the difference of slots of stator and rotor should not be equals to number of poles, n into number of poles. For example, number of poles is 6. It should not be equals to 6, 12, 18, 24 like that. So should not be equals to n into number of poles. These two are the conditions. Other than these two, generally by skewing the rotor slots, we can avoid cogging. This is very, 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 very important. By skewing the rotor slots, we can avoid cogging. This is very important. By skewing the rotor slots, we can avoid cogging. So what is skewing? What is skewing? See here. What is skewing? What is skewing? See here. This is okay. I'm going to rough this. I'm going to rough this. Okay? Okay. Now see what is skewing. Actually, in squirrel cage induction machine, for example, this is my shaft. And generally, this is my rotor. This is my rotor and this is my shaft. If generally the copper bars placed here like this in parallel in generally, but if the rotor slots placed like this, not parallel to the shaft, the rotor slots should not be parallel to the shaft. The rotor slot should not be parallel to the shaft. Nothing but, for example, this is my rotor. This is my rotor. For example, the rotor slot should be placed with small inclination. Placed with small inclination. Some for angle alpha. Placed with small inclination called as some alpha. This method is called as skewing. This is called as skewing. Here alpha is the skewing angle. Generally the alpha range around 15 to 25 degrees. Generally this alpha range 15 to 25 degrees. And they will give you the alpha and they are asking skewing factor. Skewing factor. Skewing factor is equals to cos alpha by 2. Skewing factor is equals to cos alpha by 2. Skewing nothing but inclination with some angle in not parallel to the shaft. Skewing angle 15 to 25 degrees and skewing factor cos alpha by 2. Skewing factor cos alpha by 2. This is called as skewing. This is called as skewing. Right? The skewing is done in slip ring or squirrel cage. Generally in squirrel cage only. In slip ring, no need of skewing. Generally, the cogging effect is very less in slip ring. The cogging effect is very high in squirrel cage. That's why we are using skewing here. Skewing. Right. Here. See here. What are the advantages of skewing? What are the advantages of skewing? What are the advantages? First one, cogging eliminated. First one. Second one, cogging eliminated. First one. Second one, vibrations reduced. By using cogging, we can reduce the vibrations. And third one, we can improve the starting torque. So cogging eliminates. By using skewing, we can eliminate cogging. And next one, vibrations reduces. And next one, starting torque increases. Okay. And next one, smooth speed or smooth rotation will be possible. Smooth rotation is possible. These are the advantages of skewing. Cogging eliminated, vibrations reduces, starting torque increases, smooth rotation is possible. Skewing factor cos alpha by 2. Skewing some inclination with angle around 15 to 25 or 30 degrees in generally. So cogging effect is more in squirrel cage. Cogging effect is less in slip ring. And there is no cogging in induction generator. This is about simply the cogging. Right? Magnetic locking. Cogging or magnetic locking. Here you have to remember one thing. In cogging phenomena, in Cogging phenomena, magnetic locking will be takes place in between rotor slots and stator slots. Very important, slots. In synchronous machine also, you can find the magnetic locking. That magnetic locking is very different from this magnetic locking. In this, due to magnetic locking, the rotor speed is 0. But whereas in synchronous motor, due to magnetic locking, the rotor rotates at synchronous speed. So you have to remember this. In induction machine, in cogging, the magnetic locking between stator slots and the rotor slots. Right? This is about generally cogging. Okay, the final one, in effect of harmonics. I told you already, for example, my synchronous speed is ns and my rotor speed ns by 6n plus 1 due to 7th harmonics, and due to 5th harmonics my rotor speed is ns by 6n minus 1. I told you already, ns by 5th, ns by 7th, and generally my synchronous speed is ns. Now can you tell me what is a slip? Slip S is equals to, what is formula? ns minus nr by ns. This is the formula for slip. This is very important. They are asking problems in GATE and IES and many competitive exams. Let's see what is S. S is equals to ns minus 7th group, nothing but positive sequence, nothing but if the magnetic field is in this direction, the rotor also rotates in the same direction. Positive sequence, nothing but both are in same direction, nothing but ns minus nr. What is nr? ns by 6n plus 1 divided by ns. S is equals to ns into 6n plus ns minus ns by 6n plus 1 into ns. Take the LCM and do the solution. Ns gets cancelled. So S is equals to 6n into ns by 6n plus 1 into ns. Ns gets cancelled. Ns gets cancelled. So S is equals to 6n by 6n plus 1. This is finally the slip for 7th harmonics. 7th group harmonics are 6n plus 1 harmonics. So what is slip here? 6n by 6n plus 1. Can you expect what is slip here? Can you expect what is slip here? 6n by 6n minus 1, sir. Yeah, good answer. Here the slip is 6n by 6n plus 1. And can you tell me what is slip here? Here slip S is equals to 6n by 6n minus 1, sir. Very good. I will give you options. 6n by 6n minus 1, option A. Option B, 6n minus 2 by 6n minus 1. Option C, 6n minus 1 by 6n minus 2. Option D, any of the above, like that. Now, tell me what is the slip for this 5th harmonics. For this 5th harmonics, nothing but negative sequence. What is the slip? Hold the video and do the solution and give me the answer. Very, very important. And I will give you surety, 90% of people do the wrong answer. 90% of people do the wrong answer. Tell me what is slip. And I am telling you the correct answer is option A only, 6n by 6n minus 1. But no people get this answer. The people get like these answers. Tell me. Do and check it. Is your answer is 6n by 6n minus 1? You are analytical student. If your answer is like this, you are a common student. If you get any answers in this, you are a common student. If you get this answer, you are analytical student. Check it once. You are analytical or common student. Check it fast. Hold the video and check it. For example, common student, how they do. Common student, ns minus nr by ns. So s is equals to ns minus nr is equals to ns by 6n minus 1 divided by ns. Common students can do like this. ns into 6n minus ns and minus ns by 6n minus 1 into ns. Nothing but s is equals to ns common. If ns common, 6n minus 2 by ns common 6n minus 1, ns gets cancelled. Sir, my answer is 6n minus 2 by 6n plus 1. I got 6n minus 2 by 6n minus 1. I told you already, this is the correct answer. This is wrong answers. I told you already, 90% of students gets these answers. And 90% of students gets this second answer only. But I already given you, this is the correct answer. So how we can get the correct answer? How we can get the correct answer? What is the correct procedure? The same procedure, sir. S is equal to ns minus nr by ns actually. And s is equals to, I told you already, negative sequence. For negative sequence, if this is the synchronous speed, the magnetic field, for negative sequence, the rotor rotates in opposite direction. If rotor rotates in opposite direction, S is equal to ns minus nr by ns. Negative sequence. If both are in opposite direction, what is the relative motion? N1 plus N2. N1 minus of minus nothing but plus N2. What is answer actually here? Minus of minus Nr. That's why Ns plus Nr. This is the common mistake. Then you can get option A. Let's check it. Ns plus Ns by 6n minus 1 by Ns. Do the answer. 6n into Ns minus Ns plus Ns by 6n minus 1 into Ns. Ns gets cancelled. So S is equals to 6n into Ns by 6n minus 1 into Ns. Ns gets cancelled. So answer is 6n by 6n minus 1. 6n by 6n minus 1. 6n by 6n minus 1. Option A is the correct answer. So this is simply the slip calculations. Effect of harmonics in that the slip calculations. 6n by 6n plus 1 for 7th group, or 6n plus 1 are positive sequence, and 6n by 6n minus 1 for 5th group are negative sequence, or 6n minus 1. Don't forget this. Negative sequence nothing but opposite direction. Negative sequence nothing but opposite direction. Opposite direction nothing but plus. Minus of minus plus. Right?